And I'm Mrs. Flinchbaugh, and we're both 5th grade teachers at Douglas MacArthur Girls Leadership Academy.
Hey, I have a Kit Kat. Would you like some?
Yeah, can I have half of it?
Maybe 2/4.
Which one's bigger?
Well, I don't know. Let's see. What do you think? Is half bigger than 2/4? I took my one whole Kit Kat and I broke it into 4 equal parts.
So if I take 2 of these equal parts and you take 2 of those equal parts, then we'll each have 2/4.
Or we each have half.
Is that because they're equivalent?
They are equivalent. So if you look, we have 2/4 as our fraction. Our numerator is labeled, and that is the 2. Our denominator is the 4.
Okay, so if I have 2/4 and 2/4, we also said that that is split into halves because Mrs. Kinney would have half of the Kit Kats and I would have half of the Kit Kat. So we need to figure out how we can make 1/2 and 2/4 to show that they are equivalent. So let's see what we can do. Oh, let me use a bunch. All right, so I have my 2/4 and I'm trying to make it equivalent or equal to 1/2. Well, I need to think about what can I divide 4 by to get to 2, because we know that 4 is a bigger number than 2. So multiplying wouldn't make sense. So we need to divide. Well, let's think. 2 can go into 4 how many times? 2, 4, that's 2. So if I divide 4 by 2, that equals 2. My rule is with equivalent fractions, whatever I do to the bottom, I have to do to the top. So that means I have to divide 2 by 2, and 2 divided by 2 equals 1. So if I divide 2/4 by 2, that gets me a half. That's how they're equivalent.
So as Ms. Flinchbaugh explained, 2/4 is equivalent to 1/2. So now I'm going to show you how 1/2 can be equivalent to 2/4 by using multiplication. So if I have 1/2 and it equals 2/4, I need to look at my denominators first. What times 2 will give me 4? Well, if I think for a second, I know that 2 times 2 equals 4. My rule says whatever I do to the bottom, I must do to the top. So 1 times 2 gives me 2. So there again, 1/2 is equivalent to 2/4. Now that we know how to find equivalent fractions, let's practice. So if I have the number or the fraction 3/4 and I want to find an equivalent fraction, can I just use any number as long as I follow the rule, whatever I do to the bottom, I must do to the top? Yes, I can. So I'm going to use multiplication. If I multiply my denominator by 4, I must multiply my numerator by 4 as well. So then my new fraction, or my equivalent fraction, would be 4 times 4 is 16 for my denominator, and 3 times 4 is 12 for my numerator. So I have 3/4 is equivalent to 12/16.
Okay, great. Let's try another one. So I'm going to start out with the fraction 15/20. So that means in my one whole, I have 20 parts, and I'm using 15 of those 20 parts, of whatever it may be, candy, Kit Kats, whatever. So I'm going to try and make an equivalent fraction for 15/20 using division. Mrs. Kinney used multiplication, but you can also use division, so that's what we're going to do. So let's think of a factor 15 and 20 both have. So if I think in my head, one factor that both of them have is 5. So I'm going to divide both 15 and 20 by 5 because whatever you do to the bottom, you have to do to the top. So 20 divided by 5 and 15 divided by 5. Now let's see what equivalent fraction I get when I do that. So 15 over 20 is going to be equivalent or equal to 3 over 4. Okay, who knows what fraction of the Earth is covered with water? I know.
7/10.
71/100.
Wait. Who's right? I'm right.
No, I'm definitely right. Let's see.
Right.
Let's see.
7/10.
70/100.
They don't look the same.
Maybe they are the same.
Okay, so 7/10 we're saying is equivalent to 71/100. So in order to make it equivalent, my rule says that whatever I do to the bottom, I must do to the top. I want my denominator to equal 100. So 10 times what gives me 100? That's right. 10 times 10 gives me 100. Again, if I do it to the bottom, I must do it to the top. So 7 times 10 gives me 70, which means that 7/10 is equivalent to 71/100. So we both are right.
Another way we can show equivalent fractions is by drawing number lines.
We're going to use some chalk to draw number lines on the concrete.
Our number line will start at 0
And end with 1.
If we split our number line into 2 equal parts, that means that we would put our line right in the middle, and that would represent 1/2.
So now we're going to draw another number line. We want the number lines to be the same length.
Again, we'll start at 0
And end with 1.
except this time we want to split our number line into 4 equal parts.
So if we're splitting our line into 4 equal parts, what would our denominator be?
That's right, 4. Now we need to think about what our numerator is going to be for all of these parts.
So we go from 0 to 1. So our first fraction on the number line will be 1/4. The second dash will be 2/4. The third dash will be 3/4. What do you think is going to go on the fourth dash? I have 1 whole. That's right, it's going to be 4/4.
Let's take a look at our number lines. What do you notice? If we look at our whole, that is equal to 2/2. If you look down at our other number line, 4/4 also equals a whole.
2/2 is also equivalent to 4/4. What else do you notice about our number line? Well, if you take a look at 1/2, what is it equivalent to? 1/2 is at the same place as 2/4. So is 1/2 equivalent to 2/4? Yes, it is. Can you make a number line and section it off into 8 equal parts? This is what your number line should look like. As we step back, let's take a look at all 3 number lines. What do you notice? Do you see any equivalent fractions? Well, I notice that 1/2 is in the same spot as 2/4. But when I look at my 8ths number line, I also notice that 4/8 is in the same spot. So if you're saying that 4/8 is equivalent to 2/4 and to 1/2, you're correct.
I notice that 1/4 is in the same spot as 2/8. So if you were thinking that 2/8 and 1/4 are equivalent, you're also right.
I also notice that 3/4 is in the same spot as 6/8. So if you're thinking that 6/8 is equivalent to 3/4, you're correct.
And lastly, if we look at 2/2, it's in the same spot as 4/4, which is also in the same spot as 8/8. So if you said that 8/8 is equivalent to 4/4, which is also equivalent to 2/2, then you're right.
We're going to be making equivalent kites, and we're going to do this by using plain white paper,
Some glue,
yarn,
scissors,
tape,
and markers.
and popsicle sticks. And if you don't have popsicle sticks, you can use any type of sticks that you find outside. So if you take a look at our equivalent kite, we call it an equivalent kite because I have divided one side into 16 squares. And if I count how many hearts I have, it equals 8. So 8 squares are hearts out of my 16. So my fraction would be 8/16. And when I flip it over, I only have 2 hearts out of 4 squares. So my fraction would be 2/4. 2/4 is equivalent to 8/16. So that's why I call it an equivalent kite. So to begin, we first want to take plain white paper and just fold the top down to meet the end. This extra piece, you're just going to cut it off and use it for scrap paper for something else. Open it up to where you see the square. Then fold it in half. Once you have it folded in half, fold it in half again. Open it back up, and you see that I have all of my creases. I have 1, 2, 3 creases. Now I'm going to fold it in half in the opposite direction. That's right, you're going to fold it in half again. Now open it up. Once you open it up, you're going to see that you have 16 square boxes. Now within these 16 square boxes, I want you to color 8 of them any color or any shape that you like. I'm going to do my squares in blue. If we have 16 squares, that means I want to do half in a blue square for my shape. So I'm going to color in 8. So 8 out of 16 of my squares are blue squares. So my fraction would be 8/16. And my remaining 8 squares, I'm going to put a pink flower.
I think I'm going to put a pink heart.
So my fraction again would be 8 out of 16 would be flowers. So 8/16 of my squares are flowers. So now I'm gonna set this aside and I'm gonna do another one for my back side. Fold your paper.
We're going to follow all the same steps until we get to folding.
Cut that extra piece off on the bottom. Open it up to where you see your square. And this time I want to make my back side to match my fronts using an equivalent fraction. So instead of having 16 squares, I think I can make an equivalent fraction by just folding it in half. Open it up, turn it, and fold it in half the other direction. When I open it up, I see that I have 4 squares. So if I take 2 of my squares and I make them flowers, and the other 2 squares, that blue squares, that means that I would have 2/4 equal pink flowers, or 2/4 equal blue squares. 2/4 is an equivalent fraction of 8/16. Perfect. So now I'm going to take one and flip it over, but I want it to be like a diamond. So I'm going to turn my paper to be diamond side. And this is where our popsicle sticks, or our sticks outside, come in. We're going to take our first stick and place it right smack in the middle. And then we're just going to take any type of tape. And I'm going to put one piece on the top and another piece on the bottom. Once I have that done, I'm going to take my other side of my kites and I'm going to put it into a diamond. And I'm going to take my other stick, but instead of placing it in the same direction, I want it to go across. So I'm going to put it across and use 2 pieces of tape. So now I have 2 pieces, front and back, with my sticks on the inside. I'm going to take my string and I'm only going to tape it on one side from my stick down. I'll probably only use 2 pieces of tape. It doesn't have to be perfect. I'm going to use one more just to be safe. Okay, so I have one with my string and 1 stick, and the other one with just 1 stick. Now I'm going to take my glue and I'm going to put glue just on the edges of one side. A little goes a long way. And I'm going to match them together. Gently press it down. And there you have it, your equivalent kites. I wonder if it'll fly.
Maybe.
Let's try it. You can practice equivalent fractions using anything around your house. Some of the things that we have is crybaby candy,
Some Play-Doh,
and some starburst. We are going to work on just the starburst to give you an example. So 1 bag of starburst equals 1 whole. When I open up my starburst, I want to first count them. We are going to count them to figure out what our denominator is going to be. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20.
That means that our denominator is going to be 20 because we have 20 parts of our whole bag of starburst.
So in order to make them into fractions, I want to separate them by color. If you notice, I have 1, 2, 3, 4, 5 pink starburst. So 5 out of 20.
And we'll label that pink so that we know.
I have only 2 yellow.
So that means 2 out of our 20 are yellow.
I have 1, 2, 3, 4, 5, 6 that are red.
So that means that 6 out of 20 are red.
And lastly, 1, 2, 3, 4, 5, 6, 7 of my starburst are orange.
So 7/20ths are orange.
Now we want to practice making equivalent fractions. And if you remember, we said that you can use multiplication. So I'm going to start with my red. I want to make an equivalent fraction of 6/20ths. So I'm going to pick a number and I'm going to choose 2. My rule says whatever I do to the top, I must do to the bottom. So I'm going to multiply 6 times 2. What does that equal? That's right, 12. That's my new numerator. 20 times 2, what do you think that equals? You're correct. It's 40. So 6/20ths is equivalent to 12/40ths.
If you remember, we also said that you can divide to get equivalent fractions. So I'm going to look at my yellow. My fraction is 2 over 20. So I'm going to think of a factor that can be divided by both 2 and 20 to get an equivalent fraction. What do you think a good factor would be? That's right, I was thinking 2 as well. So if I divide both my numerator and my denominator by 2, my numerator for my equivalent fraction is 1, and my denominator is 10. So that means that 2/20ths and 1/10 are equivalent fractions.
Now let's take a look at our orange. We have 7/20ths. I know that I can't make an equivalent fraction by dividing because 7, there's no number that goes into 7 and 20 at the same time because 7 is a prime number. So I need to multiply by something. So I'm going to choose the number 3. If I do it to the top, I must do it to the bottom. 7 times 3 is 21. 20 times 3, what do you think it is? You're right, it's 60. So 7/20ths is equivalent to 21/60ths.
Lastly, we're going to make an equivalent fraction for our pink starburst. So our fraction initially is 5/20ths. Let's divide and see if we can come up with an equivalent fraction for 5/20ths. So a factor I'm thinking of, and I bet you're thinking of too, is 5. So we're going to divide both our numerator and our denominator by 5. Our equivalent fraction is going to be 5 divided by 5, which is 1, and 20 divided by 5 is 4. So 5/20ths is equivalent to 1/4.
So let's recap.
Today we learned all about equivalent fractions with a little help from our Kit Kats, the Earth,
Our equivalent kites.
and our number line. Now it's your turn. Take some time to create your own equivalent fractions. See you later.
Have fun.
Hi, I'm Mrs. Anderson, physical education teacher at Douglas MacArthur Girls Leadership Academy. So today you have learned so many things about our Earth, about our planets, our solar system. So our first activity is hopscotch. Did you know that hopscotch is the oldest known outdoor activity on planet Earth? So come on and join me. We're going to go over to the sidewalk where I have my hopscotch board set up and ready to go. Here's another more conventional hopscotch board that I made. I used various rectangles, circles, triangles, even a star and a flower. I drop my stone into the one, and I have to go over it. Complete the board, pick up my stone, and then I would move on to number 2. So our second activity is Foursquare. The only equipment that you need is a ball that bounces, any type of ball, and maybe some chalk. So we are going to use the cement. The lines for the cement, they are going to be our squares. We have square number 1 and square number 4. Those two squares are opposite of each other, and then square 3 and square 2. To start the game, player in square number 1 serves to player in square 4. To serve, toss or release the ball, allow it to bounce in your square, and then tap it to square number 4. The player in square number 4 can hit the ball into 1, 2, or number 3. The players continue to hit the ball into any other square. The ball is bounced between players until someone makes an error. When the player makes the error, they automatically go to square number 4, and all other players advance, moving up 1 square. An error occurs if a player fails to hit the ball into another square. They allow more than one bounce in their own. They hit the ball out of bounds or onto an inside line, or they miss the ball completely after it is bounced inside their square. If the player in square number 1 has an error, they go to square number 4, 4 moves to 3, 3 leads to 2, and 2 moves into the square number 1. Oh, wait, 2 goes to 1. One goes down the 4 with a mistake. I'm moving up from 3 to 2. Ooh.
Never been here before, right?
Mother Earth. All right, so we're gonna try with a volleyball, a beach ball. Oh, and that is outside of the square. Player 1 gets to serve it or set it to put it into play. You can use 1 or 2 hands. Ooh. Oh, with the tip.
I get to go to 1?
2 goes to 1, 3 goes to 2.
I'm so excited.
You can create your own hopscotch board with chalk or even objects to play in your house. In the game of Foursquare, you can play with a bouncy ball, a beach ball, or even a balloon. The goal of the game is to get to number 1 and stay at number 1. Make sure that you are getting your 60 minutes of physical activity every single day. Stay safe.
Our solar system has 8 planets. We have our sun, which is our star, not a planet. Then we have Mercury, which is closest to the sun. And we also have Venus. Then comes Earth, where we live. Then comes Mars, the red planet. Next comes Jupiter, the largest planet in our solar system. And also Saturn, with its rings. And then we have Uranus. And finally, we have Neptune. Our planets are divided into 2 sections. We have the inner planets, that's Mercury, Venus, Earth, and Mars. Then we have the outer planets, which is Jupiter, Saturn, Uranus, and Neptune. We divide the planets this way because they share common characteristics. Now, the outer planets share a few similar things. First of all, they're much larger than the inner planets are. And secondly, they're a lot gassier. All 4 planets and the outer planets are called gas giants because they're mostly made of gas, and with a small rocky core in the middle. The inner planets, on the other hand, are a lot smaller, and they're much more rocky. There's a reason why the inner planets and the outer planets are so different, and maybe by the end of this video you'll be able to figure it out. 2 more objects in our solar system that you should know about are asteroids and comets. And they're similar in a lot of ways, but different in a couple. Asteroids can be as large as a continent. They can be really small, 2 feet, but they can be also as large as Australia. They're made of mostly rock and metal. Comets, on the other hand, are mostly made of ice and dust. The tail that you see is from the ice being melted by the sun, and it's actually vapor. They're small, but their tails can be tens of millions of miles long. Asteroids and comets were both formed billions of years ago when the solar system was first forming. They're basically pieces left over that are still orbiting around planets and stars that have more mass than them. Within our solar system, we actually have 2 asteroid belts. The main asteroid belt is right here, in between Mars and Jupiter. The other asteroid belt is far out beyond Neptune. The former planet Pluto is actually part of this belt, and it's called the Kuiper Belt. Furthermore, we are actually surrounded by tons and tons of asteroids in something called the Oort cloud. If our sun's in the middle, you can think of it kind of like a sphere all the way around our whole solar system. Now that we know the basics, we can go on kind of a little virtual field trip through our solar system. This is from NASA's Solar System Exploration website. And first, let's take a look at the sun. So, as you can see, the sun is a yellow dwarf star. And it's made of gases. It is not a planet. The part of the sun that we can see is about 10,000 degrees Fahrenheit. Without the sun, our Earth would be extremely cold, and we wouldn't be able to grow plants or anything else. We'll travel away from the sun now and head to the next closest planet, which, if you remember, is Mercury. Now, Mercury is the closest planet, and it's also pretty hot, as you might imagine. During the day on Mercury, the temperature can get as high as 800 degrees Fahrenheit. However, at nighttime, it can get to be about negative 280 degrees Fahrenheit. That's because this planet doesn't have any atmosphere, so it can't keep the heat that it's getting from the sun in like Earth can. Next up on our planets is Venus. You can see it right here, Sun, Mercury, and over here is Venus. Now, Venus is the second closest planet to the sun, and it is also very hot. It can get to be about 900 degrees Fahrenheit. And unlike Mercury, it has a very, very thick atmosphere that acts like a giant blanket, keeping the heat in. After Venus is Earth. And it's the third planet from the sun in what can be called the habitable zone. So it's not too hot and not too cold for life and water to exist on our planet. Earth is the only planet in our solar system that we know can sustain life. Like Mars, Venus, and Mercury, we have a hard, rocky surface to live on. But unlike those, we have water and we also have breathable air. Next is Mars, the fourth planet from the sun, and currently where NASA is trying to send people to explore. So Mars is also known as the red planet, and scientists believe that it used to have water on its surface. We can see that it has mountains, canyons, and what looks like riverbeds running across its surface. There's not any liquid water on the surface of Mars now, but there may be frozen water under the surface. There is ice on the surface in the coldest places in Mars. It's likely that if you become an astronaut as an adult, you'll be one of the people who ends up going to Mars. Next up is moving out of the inner planets to the outer planets. We will head to Jupiter. Jupiter's a really cool planet. Not only is it the largest, larger than all of the other planets combined, it also looks very interesting, and that's because it's covered in storms. The large spots you see are actually giant storms that circle around that planet. The one large storm right there that you see is often called the Great Red Spot. Jupiter also has the most moons that we know of in our solar system, with 79. So Earth has 1, Mars has 2, Jupiter has 79 moons. After Jupiter comes Saturn. Saturn is another gas giant planet, and you probably recognize it from its really cool rings. The rings are actually made up of ice and dust. Scientists actually think that the rings might be from a moon that Saturn used to have that was eventually smashed into Saturn and broke apart. After Saturn comes Uranus, and it's another gas giant planet. And it's very interesting because this planet rotates on its side, so a little bit different from all the other planets. Another difference is that unlike the other gas giants, Uranus is actually an ice giant. An ice giant, it means that most of its mass is actually icy materials like water or other chemicals that are in a liquid state, above a small core in the middle. This planet is about almost 2 billion miles away from the Sun, and it's about 4 times wider than Earth. Last but not least is Neptune. Neptune is another ice giant like Uranus, and it also has 14 moons. All of its moons are named after gods from Greek mythology. Neptune's also interesting because it has rings like Saturn. They're just very, very faint, so they're hard to see. Neptune is also the solar system's windiest world. We know that the winds go up to 1,200 miles per hour on the surface. If we look back at our solar system, we notice a few other things. First of all, Pluto. Now, Pluto is no longer a planet, a major planet from our solar system. It's now called a dwarf planet. Pluto was reclassified as a dwarf planet because as we get better at seeing things in our own solar system, we realized that there were actually other bodies in our solar system that were larger than Pluto even was. And so Pluto got reclassified as a dwarf planet and part of the Kuiper Belt. As we zoom back out, you can see other things that you might not recognize that are named on this map of our solar system. You can see several comets around, including the famous Halley comet. And as we zoom back into our solar system, and to Earth specifically, we can see 2 things that orbit Earth. The moon, and we can also see the International Space Station. Oh, and we can see the Hubble telescope. The International Space Station is where our astronauts go to do research and experiments while in space and orbiting. The Hubble telescope is basically a big space telescope that can be used to see planets and other things at a really, really far distance. The Hubble telescope has seen things that are up to 13.4 billion light years away. So we zoom back out, we'll see our moon. And our moon is thought to be a chunk of Earth that was split off after an asteroid collided with Earth, separating that chunk of us, and it got caught in our gravity. The craters that you see on the moon were formed by meteors crashing into the moon over time. This is a simulation of how the orbit between specifically the Earth and the Sun works. You can change the mass of either the Sun or the Earth, And you can also see the way that the gravity is pulling the objects. So gravity works by the bigger an object is, the more gravity it has and the more it pulls on other objects around it. So here you see the Earth spinning around the sun, and at the same time you see the moon spinning around Earth. So the Earth has pulled the moon into its gravity, and the sun has us in its gravity, specifically the Earth. As you can see, it's about 365 days to go once completely around the sun. That's how we get our year. Now, watch what happens if you make the sun have more mass. So the sun has more ability to pull us towards it. Spinning, spinning, whoop, and there goes the Earth. So it's very good that our sun is the mass that it is, because otherwise we might have some problems. Here's what it would look like if the Earth was a little bit more massive. And as you can see, it's a little bit farther from the sun if we make it more massive. Can reset it right there. Here it is again. If you make it, whoop, yep, there it goes. We can also see the same thing with just the Earth and its satellite. So here's the Earth and its satellite with no changes. And if we make the mass a little bit bigger, yep, it just crashes right into it. So the larger the mass, the greater gravitational force an object has. Too little and it would just go flying off into space. Here's a quick, easy moon sand recipe. All you need is 4 tablespoons of flour and about 1 tablespoon of baby oil. And when you mix this up, it becomes sort of like a really soft Play-Doh. And it's pretty fun to kind of smush into a flat shape and then pound it with marbles or simulating meteorites hitting the moon or the Earth. And you can see the large craters it forms.
Hi, I'm Mrs. Aquino, the art teacher at Valley View Boys Leadership Academy. And I want to start off by saying hi to my family at Valley View, and I hope you're all doing well. I hope you're staying safe, and I miss you very much. To those of you watching, I know your teachers miss you as well. Today, we are going to talk and learn and draw insects. Now, my students will look at pictures like this and they'll say, Miss Aquino, you're crazy. I can't draw that. But today, I'm going to teach you how to break these down into simple shapes so you can draw them. So let's get started. Insects. Let's find out what makes an insect an insect. First of all, an insect has 3 body parts: a head, a thorax, and an abdomen. An insect has 2 antennas, and an insect has 6 legs. An insect also goes through a life cycle. It starts with an egg, then it goes to the larva stage, the pupa stage, and then to the adult stage. One of the biggest mistakes that people make is they think this guy, a spider, is an insect. Let's take a look. If an insect is supposed to have 3 body parts and 6 legs, let's count the spiders. 1, 2 body parts. And 1, 2, 3, 4, 5, 6, 7, 8 legs. So a spider is not an insect. Now that we know what makes an insect, let's draw one. Today you will need a piece of paper and a pencil. I'm going to be using a marker so you can see my lines really well. And if you don't have paper at home, something you can do is take a cereal box and flip it over, and then you'll have a nice clean slate to work on. I also got some pictures of some insects off the internet. You can do that, or you could maybe have a book to look for one, or your phone. I have a nice big picture here of a beetle. I'm going to use this to show you how to draw it. When it comes to drawing, I always tell my students, don't look at the whole object and try to draw it. You need to break it down into shapes. We know that an insect has 3 body parts. So let's start with those. I'm going to take a look at this insect's head. I have to take off those little pinchers and those antennas so I can see just this shape of the head. So when I look at the shape of this head, it kind of comes out on the sides like this, and then it comes down kind of like that. Okay, now I'm going to look at the thorax. When I look at the thorax, it looks like a big fat jelly bean or gumdrop to me. So what I'm going to do is, if I look, it does come out past the head. So I'm going to bring my gumdrop shape out past the head, and then I'm just going to bring it down on each side. And if you look, my gumdrop has this little point down at the bottom. So I'm going to bring it over and down to the little point, and bring it over and down to the little point. Okay, so 2 simple shapes. Let's look at this big giant abdomen. If I look at it, it's just a big letter U. And if you notice, it only comes out just a little bit on the sides from that thorax. So now I just have to, and my U has a little bit of a point at the bottom. So I'm just going to curve it out, curve it in, and then this side, curve it out a little bit, and then curve it in. Okay, I already have most of my bug done, and all I did was draw the 3 body parts by breaking it down into simple shapes. Now, let's take a look at the legs. Just like you and I have a wrist and an elbow and a shoulder, a bug also has elbows. He has segmented legs. A lot of the times my students will say, oh, okay, Miss Aquino, I have 3 body parts and 6 legs. Okay, 3 body parts, 6 legs. This is not what an insect looks like. He has segmented legs that bend so he can walk. So I'm going to break my insect down into shapes. And what's really cool about an insect is that he has symmetry. Symmetry means if I draw a line right down the center of this insect, he is going to be the same on both sides. So this leg is going to match this leg. I'm going to start with this first section of the leg. It comes out of the thorax, and it's shaped like that. The second part of the leg slants in a little bit like this. Kind of a little triangle, rectangle-ish. And then the top section comes up like this. Now, I can add those little details on later, but I do know if my insect has symmetry, then I have to draw the same thing on the other side. So I'm going to make the mirror image of this leg the best I can. And then this piece is going to go this way. And then I can't forget those 2 little things on the end. All right, let's go to the next 2 legs. The next 2 legs go out the same way. They come out of the abdomen this time. And then they slant down. And they're kind of this triangular shape. And then they go this way. There's that triangular shape again, and those 2 little pieces. And then I have to make my bug symmetrical. So I'm going to go this way, then this way, and then this way. Now, my last 2 legs are very similar to the middle ones. So I'm going to start with this piece going this way, Now this one slants in towards the body a little bit, and then it slants out this way. And so now make that mirror image. We got to have that symmetry. Symmetry is something I always go over with my students at school. So they always should know that symmetry means the exact same thing on both sides. It's got like a toenail. Okay, now let's not forget those antennas. Now he's got some really interesting antennas, but if you look at them, they're really just long, round. They almost look like a baseball bat. So I'm gonna do my two kind of baseball bat shapes on either side, and then he does have these two kind of little jaws or feelers coming out of his mouth, so I'm gonna put those in as well. Okay, now I have the basic shape of my bug. It looks great. Now it's time for the details. So now I have to make sure that when I do my details, I make them the same on both sides. So this bug is pretty easy. He's just got some stripes on his abdomen. And what I like to try to do is do the same amount of lines. So if I only did 3 lines there, then I'm only gonna do 3 lines on this side. Now you might wanna do more lines or change it up a little bit, just make sure it's the same on both sides. And then I might want to add some of these shapes on his feelers and add those details to that. I can see that he's got kind of these cool shaped eyes on either side. And I can just start to take all my details and add to it. He does have kind of these little spiky feet, and I just start adding a little bit at a time until I get the perfect insect. So all you have to do is get yourself a piece of paper. It's very simple to get success as long as you break it into shapes. I hope you enjoyed this. I hope you really try to do this, and stay safe, everyone. Bye.